Hi everyone, welcome back. This is Raju from Smart AI Technologies. In this video, I'm going to show a project called Medicine Plant Classification using Deep Learning and Machine Learning. So whatever you are seeing on the screen is our complete web application after integrating our model. So the web application was done based on intention of showing you e-commerce website where we are already selling Ayurvedic products. Few Ayurvedic products and their details you can see here. Okay, it looks very real and even you can see the pricing. Okay, so this is how the website is built. It contains almost all the things that low-end e-commerce website will have. Now as a first part of it, we give an option for a user where he can click on this button and there will take him to our AI model. So in this page he can upload the images whatever he is having. So for now we are giving option for uploading images, but in future we will be helping you with real time. That is, when a person click on button, he will be given a camera option. So automatically camera will open and it will capture the image and it will detect. For now we are giving upload option. So whenever you will approach to us for the project, we can add that. Okay, it depends on the students and your requirement. Even you can change the requirement. So we Smart AI Technologies provide projects for MTech, PhD, B and BTech and so many other type of students, and also even for some startups. Okay, so whenever you take project from us, it will include documentation plus coding. It will start from your base paper selection, which base papers to refer, and how to decide our own proposed methodology, and whatever the project that you are seeing here, it is having its own methodology in the back end. It means it is having its own model and everything in the back end, and we have a particular life cycle followed. For example, we done so many special techniques in pre-processing, okay, and cleaning and model building and model analysis that we'll discuss once we go through this website. I will discuss with you the IEEE papers and what are the proposed methodology and what are already available in the previous IEEE papers. All those things we'll see. Okay, first we'll upload few images here. I have a sample of images, we'll check with them. And in our case we have around 80 classes. Okay, we built our model for 80 different classes of plant. This is arali, so I upload an arali leaf. Now you see, for every plant I will get these features. What is medicine content, disease cured, what type of disease can be cured by this plant, what is there any age restriction, is there any gender restriction, or whether pregnant women can use it or not, and mode of use and doses per day. So when it comes to arali, you can see alkalinide, flavonoids and funnies. So diseases it can cure is skin conditions, rheumatism and asthma. Here is restrictions, says for adult. Okay, consult a doctor for children. This is a special thing they are mentioning. All these things are decided by our model based on the images. Okay? No gender restrictions, and when it comes to pregnant women, better you should consult doctor. And mode of use, so topical application paste. Okay, so they are asking us to use it as a paste. Now doses per day, how it can be taken, okay, as directed by the Ayurvedic practitioner. So they are not mentioning particularly one time or two time, because maybe this particular leaf needs uh, practitioner support to use. Just like that, we will see 2 to 3 different plants and what the result will be, we'll check. So now just like Karadi, next I will go for Amrutavalli. Okay, I will be uploading this and I will click on predict. Now I should get the detail first. Okay, the detail for Amrutavalli. Okay, that was our uploaded image. So now what is the medicine content? Alkaloids, flavonoids and glycosides. Okay, glycosides. Okay, and diseases cured are boost immunity, fever, respiratory disorders. Safe for all ages. Okay, no restriction, age restriction, no gender restriction. And again, when it comes to pregnancy women, consult doctors during pregnancy. Okay, and then mode of use, powder, in the form of powder you can take, or they mention like directed by Ayurvedic practitioner. And doses typically 1 or 2 teaspoon powder as per practitioner advice. Okay, again it will advise. Why they will again ask for practitioner advice in nothing but it should not like for example for some patients, okay, who are having levels, okay, there will always be a levels of uh, diseases, okay, so in which level the patient is, based on that it should guide, but it don't know which level, but normally it will tell that okay, this particular plant is there, you can use for it. But again, if you are having any severe or medium, it depends, okay, so you need to approach the practitioner better. But normally why we use, why what is the useful thing from here is, what is this amrutabali, okay, we want to know what is the name of it first of all, then amrutabali, and what are its content and what are the diseases it will cure mainly, okay. And again the age restriction, gender restriction, again pregnant women normally every medicine says you can't use, okay, when it comes to pregnant women. And mode of use, again this is our needed thing, doses for a day, sometimes you need practitioner support. Now I'll go here. Already amrutaballi is done, so now I'll upload aloe vera. So when uploaded aloe vera, it says detail of aloe vera, what are its contents and why to use it, and is there any restriction. So aloin, polysaccharides, vitamins and minerals. What are diseases that can cure this? Mainly skin condition, okay. So digestive problem also, it can even useful for digestive problem also. No age restriction, no gender restriction, and when it comes to pregnant women, you should consult doctor. Then it will be application, okay, like paste or like that, it can be applied on screen, and 2 to 3 times a day, 2 to 3 times a day you can use it. There is no problem in using more than once. Try this. All these are real-time captured images with mobiles or like that. So medicine content, vitamin C, tannins and flavonoids boosts immunity, improves digestion and hair health condition. It's safe for all ages, no gender restriction, and for women or for pregnant women also it says generally safe. Okay, so even they can use it. But again, if you consult doctor, that is fine. But anyway, it is not that much dangerous to even pregnant women also. Now, consumed raw as a juice, or you can take in this form. Okay, in any form you can take this. 1 to 2 amla fruits, or if you are taking it as a juice, you can say 20 to 30 ml per day. You can take it. So this is how our model is working. So it is working very accurately. So we are having better accuracy than the previous IEEE paper. So we proposed our own models, our own methodologies. We'll discuss that, but before that we'll discuss some previous IEEE paper. Then we'll find out what are the problems are there in that paper. Then we'll go and propose our own methodology to overcome the issues or problems. The first paper that we are going to see now is automatic classification of medicinal plant species based on color and texture features. So in this feature, we'll check first what is their methodology, and then if they have provided any data about their data set, then we'll check okay what their data set is having. So here you can see under image pre-processing what they are doing. Okay, they are doing segmentation. Now in this paper they are mentioning that under pre-processing they are first isolating the each leaf. If they are taking an image of plant, they are trying to take out only leaf region. Okay, once the image is segmented, okay, that they are saying like executed manually. So this they manually executed or took out the each leaf from the plant. Okay, then they done standardization over that each leaf. Now after doing this, they are trying to extract features. Okay, they are mentioning like they are trying to extract the color based features, and other one was texture based features. Okay, so based on these three things, they want to extract so much of data. So how they are doing it, you can see here. These are all the features they are extracting from each image. From each image they are extracting 18 features, and the last one is class label, which is species that is. So once they extracted this, they trained machine learning models over it. So what are the machine learning models they are using is 5 machine learning models they are using. They are mentioning like here: decision tree, k nearest neighbor, weighted k nearest neighbor, and random forest classifier, multi-layer perceptron network. So these models they are using and they are training, and they are trying to present everything as a box. What is the accuracy, okay, of each model? What is the mean and standard deviation of that median? Okay, and also this we call as a classification report, precision recall F1. So when you see F1 score here, median, you can see that, okay, mean or median, you see there is a lot of difference from different models, F1 score difference. And decision tree is good among them, but random forest classifier is better than every model. So it is around 97% F1 score. Why I am concentrating mainly on F1 score is it will be giving us, okay, how much accurately the things are getting predicted. And also here this F1 score is not much clear. Okay, what can be done here is we need F1 score for each classes in each model. In that case we will be able to see, okay, they are mentioning mean, okay, so they are taking average of it. So we don't know for each class how much is the F1 score for each class. For example, I will tell you, in our case we have 80 classes, say neem, amla. Okay, so now for amla, if it is 97%, that's fine. For neem, if it reduces to 76%, then also when you take average, if some other classes are very high, it will show very high only. The reason I am presenting this is actually when our data set is unbalanced, okay, whatever the data set we take, there will be some problem. Okay, the common problem is unbalanced data set. So in the case of unbalanced data set, some classes will get suppressed. Those classes which are having less number of images will get suppressed. So on that case, even though if you are taking mean of that f measure or f score, f1 score, what you say, so in that case if you take average 97, it doesn't mean like all the models are having 97, nearly 97. Maybe there are some models which were having less images. If you build model without balancing them or without handling the unbalanced data set, there may be the issue of less f1 score for that particular class. So it is not that much clear here. So they are taking mean of that, mean or median or standard deviation. So here, which is not that much clear. Once we get that what is the F1 score of each class, then we will understand, okay, whether our model is working properly or not for all the classes. Okay, you should not overtrain or undertrain. And unbalanced data set is the biggest problem we should handle in these cases. So again, in this paper they are mentioning like they are having a data set of less number of images. So this particular plant they are taking 12 samples, you see, but in our case we are having 10 GB of data in storage way I'm telling, and the data set is very huge. So we are having around 80 classes of data, okay, each containing more number of images, more than minimum, more than 100, 200, nearly 1000, or some are having very less. Okay, that's what our data set was unbalanced. So some are having around 7 100 or like that, fewer and 25, 30, like that. Okay, from high number to very low number in our data set, and they are very high quality images. So in that, our case is very unbalanced data set. So these data set elements here, so what are they considering are just small samples of it, but in our case it's very huge data set. So we should handle our data set differently. So we are having different problem with us. This case, again, the extracting, okay, all these features they are extracting from each image. But if you are given a plant, from that they are mentioned like they are manually extracting each leaf from it. And as I told you, models they are using 5. Okay, they are using texture and color based features, they are extracting it manually. Not manually, they are writing code to extract these things, and they are getting training accuracy around, okay, they are mentioning like around 97, okay, average, on average. Okay, finally we should go with the best one. So that is random forest. Okay, its accuracy is around, what is the accuracy, 97.61, which is the best accuracy of this project. Now we will go for the paper 2. So the title of paper is real-time identification of medicine plant using machine learning techniques. As this paper says, they are using machine learning techniques itself. Now, what are the features they are taking as an input, and all those things we'll discuss. So I'm not going through all the things, abstract, introduction, like that. So you can read it. Okay, it's bit more theory, but our requirement is in the methodology. So we are going to check that. Okay, methodology. So even they are taking all leaf elements, they are doing segmentation, but again there is a difference. This data set is very clear, but in our case our data set is having random background, maybe wall, maybe land, maybe curtain, maybe soil, normal soil. Okay, it's real data set. Okay, so captured by mobile. So our data set is realistic than this, where this is being captured over a background, good lighting. So again, they are following a procedure called segmentation. Nothing but they are taking out only leaf area, making everything black. And then feature, again, these people are also extracting the features one by one, and they are going to make that as an input for the models. They are doing grayscale, and maybe they will be applying some filters. Here, as they mentioned, they are using EXZ and EXR index. So these are higher sensor based index. So when they pass through these leaves already having, they will get only leaf part. So they are not doing edge detection. They are mentioning they are not doing edge detection because already the technology they are using EXZ and EXR indexing. With that, they are getting only leaf part. Once they got it, they are going to use logistic regression as a machine learning model, and they are going to feed it. For logistic regression model, they are getting 93% accuracy. Multi-class classifier, they are getting 80% of accuracy. Now we will go with another IEEE paper which speak about AI based indigenous medicinal plant identification. In this paper mainly concentrate on deep learning based. Okay, so what are things they are considering? What are model they are using? So again, in this paper, you see the images are captured in good background. There is a nice background and good lighting. All these things matter. What data set are you using, and in which light intensity the data set are you using, and what type of pre-processing you are doing? All these things matter. If for example you say your friend, okay, with good lighting you can detect him, but if you push him in little bit darker, and if you try to identify, it's a bit hard for human beings itself. The same thing happens for our models. So our data set, whenever you have a data set of random intensity, random light, okay, in unknown background or some fuzzy background. In that case, if you train your deep learning model or machine learning model to the good level, that will be the best model over the model which is trained on the clear background image data set. In our case, we're having multi-leaf input. So here single leaves are there. First of all, data is different. That's what I want to mention. When the data itself is different, the process that we need to handle, it should be different. All these block structures, okay, you don't get confused. These all are part of machine learning life cycle or data science life cycle. Okay, there is a life cycle where one process should follow other. Okay, these things are part of it. So they may be written differently in a different way, but you will understand it once you approach us. We will discuss in depth about this. What is this splitting of data set, 80 or 20, 80 training, 20 testing? Is it fixed one, or why we go for 80/20? Whether we should go 80/20 always with our data set, and according to our data set, what should we do? All those things like that we can discuss. Okay, these papers are just for base papers. Okay, based on these should we should decide our methodologies. That our methodologies will propose the methodologies. Okay, once we go through these papers, they are mentioning little bit about the layers of deep learning, what each layer will do or like that. It is fine. Okay, so the summary of this I will tell you what they are doing. Actually, in this paper they are using three different models. One is CNN, another one is VGG16, and another model is VGG19. So CNN is giving 95.79, VGG16 is giving 97.8, and VGG19 is giving 97.6% of accuracy. And then there is another IEEE paper which I'm trying to refer. In this paper also, Ayurvedic plant identification based on machine learning and deep learning technologies. So this is actually what we are trying to do. Okay, over this paper only we are making so many improvements because our title is similar to it. We are also trying to go with machine learning plus deep learning techniques. But when I go through this paper detail, they are mentioning two things, okay, which is very clear. They say like they have 100 species for every 15 different, sorry, 15 different species with 100 elements in it. So around they are having around 1500 images, and uh, they are not mentioning which algorithm they are using, but they are mentioning like they are getting 92.7% of accuracies. Now we gone through four papers. Okay, in our paper what we gonna propose from these papers, the last paper was just a extra for you. You can go and download the IEEE paper of this and you can check it. Okay, and now what methodology we are proposing from all these papers, the thing is very clear. Our first methodology will be, we want to balance the data set. So no data set will be balanced data set. Normally there will be unbalancing when it comes to image data set, normally plant related. When it again comes to plant related data set, data that we gonna collect or someone collected it will always be unbalanced itself. The reason is few plants are very easy to get. Okay, and with the different conditions. Okay, not a single plant you are taking 1,000 times the same picture, it won't happen like that. Okay, the data set that we have is collected. Okay, that is being collected in different scenarios. For example, you are taking a neem leaf that is being captured in different conditions. Okay, there are different range of conditions. So like this few leaves are very less. Okay, that those graphs you will study about it, why unbalanced data set is a problem, how to solve the thing. So first we are proposing a technique called augmentation. For now we are going with augmentation. And you may ask me whether only this is a solution. No, there are so many other solutions. One among them is a GAN, generative artificial neural network. If we have a less, for example, if I have 25 images for name, I should get minimum 100. In that case, I can generate from this 25, 75 extra images, and I can make my dataset balanced using GAN, Generative Artificial Neural Network. That is another option, but for now we are going with augmentation. Augmentation nothing but if I have 2 to 3 images, okay, 2 to 3 images with me. For example, let us say here he is a one image, okay, he is a one image. From E I will generate like this different images, 8 images, okay. We call that as an augmentation. In this case, those people are extracting the above images and they are pasting here, they are manually cropping them, okay. But in our case, we take one image and we apply intensity change, orientation change, and shift change, zoom range, okay. So for one image you can generate 4 different combination of images. For example, if I take E as a one image, I can generate like this, tilt different angles. I have around, say, minimum, if I tilt it by 15%, 15-degree difference, I may get more images. Again, I will change their intensities, again I will change their zoom ranges. Like that I will do over the images, and I will create multiple images from the available images, so that whichever the class was having less number of images, now they will become balanced number of images to the higher class. So this is our first method, that is we are concentrating on balancing our data set, so that again our model should not overfit or underfit. We are trying to solve that, and it will lead to good F1 score. Again, I am mentioning F1 score is very important. You can't live like that. When you get normal training accuracy 97% and testing accuracy around 92%, it doesn't mean that your model is working very well. If F1 score of one class is below 70%, then also there is some problem. So we need to check like this, okay, what we can do to that class. So this is our first methodology. And again, next thing that we are going to do is during pre-processing. Now, what are the pre-processing techniques that we are planning to apply on our images? The first one is color thresholding. As you know, our images are not that much captured clearly. There is a lot of background or different backgrounds, different type of backgrounds, okay. Leaf sometime kept on carpet, sometime on table, sometime on soil. Sometimes the leaf it is in tree itself, then the images are captured. So, different range of data are there, okay, in that case. But leaf color remains same, it is green itself. Now with the help of HSV, okay, color format, we can concentrate on only green color and we can take out, just like a segmentation, okay. The other way of segmenting that are concentrating more on the green colored element on the camera, that is leaf itself. And then we are going to do Gaussian blurring to remove the noises. Then we're going to do edge detection with canny filter. This is our first step or first plan. So we are applying, for now we are applying this. Again, some students may ask, why only canny, why not some other, okay. In that case, there are so many other techniques, okay. So whatever we are using here, maybe to remove the noise, not only Gaussian, there are so many other type of filters that we can apply. But why we are going with these things are, these are already proved they are better than other model, other technique, okay. So normally we are going with it. If you want to change, we can change these things and we can work on it and we can give you the result if you approach us. And as I mentioned again, I will tell you one thing, we provide you complete hand-on and support till your external presentation. Now the next thing is erosion and dilation. It is to remove the boundary noises while cropping or while segmenting. We want to remove that noise, so that we are going with erosion and dilation. Now if I want to take care of the area of that element, we go with contour detection, contour detections. So this again another technique. Now in the end we are going to do median filtering to remove the noise on the given image, a leaf image. We're going to remove the inner noise with the help of median filter. Once all these things are done, okay, and our image is good now. Okay, we are having our own leaf image, everything is removed, no background and all those things. We are going to smoothen it. Okay, smoothing and enhancing the particular feature in that leaf. For example, say veins, that lines goes in middle of that leaf, no center, so that, and smaller veins or small lines which goes on the leaf, you can change the color, find them and change the color of them. Like that you can highlight, the particular region. Once if you do all those things, you are helping your models to identify it better. So it is just like you have a, let us say you have 1,000 different ships. Okay, just say you have 100 ships given to you. Now if you want to identify which ship is which brand, okay, normally by looking you can say okay which ship is which breed. Okay, now instead of that, what if manually their body is colored little bit with the different colors, green, red, like that, based on their breed type. Then it will be very easy again for you to detect. Again, if I do something and I go and I can change the color of their horns. Okay, I make colors, okay, on their horns or like that, or their forehead I will paste another color, another some mentioning. Okay, it means it's directly saying to the data how much you want, you will label. Okay, by finding out and label something, maybe their color, maybe their area, maybe their edges. So based on that, the accuracy will always go on increase. Okay, so, due to that we are trying to play with the data and we want to do something with the given images so that my model should learn faster and better to detect. Now these things are till pre-processing. Now what extra we are doing in model building, we are planning to go with, as I mentioned, machine learning plus deep learning. So when it comes to deep learning, we are planning to go with CNN, our own custom model, and then we will use ResNet, MobileNet, and VGG. Once these things are done in machine learning, we use random forest, XGBoost, and decision tree. These models we are going with machine learning criteria. So we are getting better accuracy. Once if you contact us, I will share you the complete complete classification report of our models, and then we'll show you the demo of our project that we built. Okay, you can see the demo, how we are running and what result we are getting, what input we are giving when we are verifying that. All these things you can see how the demo is working. Based on that, you can decide, okay, whether you need our support or not. Here you can see I'm just trying to show you one small code where I'm loading the saved model, and this model is level 1 model. We are not applying all the pre-processing techniques in it, so that I am trying to show you. And I'm trying to load that model and apply one by one some images, and I will test it manually here. Anyway, we are using this in our backend process of our website, okay, which you already saw starting. But now we will see, okay, how we will load that, okay, already trained model. So first I'm importing all the libraries. In this case I'm trying to use TensorFlow and Keras based deep learning. Now once I import the libraries, I'm going to import that model, okay, which I trained. This model I'm going to import it with the help of again load underscore model function of TensorFlow. Now with help of CV2 or OpenCV, I'm going to import one image from our folder to Amritaballi. This one I'm first uploading it, just I'm feeding the path of that image. So it will take, it will resize it, okay, then it gonna feed to my model, my loaded model. Then it will give me the probability. So any deep learning model will provide us the probability. How much probability that it belongs to class 0, because we have 80 classes. So how much probability it belongs to class 2? 69%, nothing but you can see the entire list. There is no number which is greater than 69. It means that model feels like the image you provided, there is a possibility, 69% possibility that it belongs to class 3. So now when 69% is the highest number at location 3 in our list, we our list of their names. Okay, so you can see in this what is the third element, amrutaballi. So indirectly saying that whatever the image you are feeding is actually amrutaballi. So I'm extracting that. Okay, and I'm displaying with the name. Which leaf is that? You can do this on different images, different leaf images, and you can test it. The same thing what we are testing will be useful. Okay, once you test it in Jupyter Notebook, you will take that and implement in your front end and back end. Again, this model, whatever I am showing you, this loaded model is level 1 model. We didn't apply all the things here. So what where our web application, it is containing a lot complicated model. Again, you may be getting confused. What is the difference between the complicated model and this? Is that the model during the training, the data input provided after so many pre-processing techniques is the best, that the original model. But in this, we feed it, normally the data is converted and feed it directly without much pre-processing. Okay, so that's why this is a level 1 model, I can say. This is how we use loaded model to predict the given image. So if you approach us, we will be providing you the code, classes, documentation support. We provide complete IEEE based machine learning, data science and artificial intelligence projects for MTech, BTech, PhD and few hobby researchers also. Means they are already in some good position and they want to write papers. Okay? They want to add those research papers to their resume. It means they want to add it, okay, as a title to their name. Them also we work and we provide them technical support whenever needed. You can approach us and get our support, and I think it will worth it. Thank you very much, and don't forget to subscribe and like our channel, and we'll be coming up with few good projects which are very useful for any researchers or students. I think all these things will help you further. Thank you very much.